Unfortunately, no dog lives forever, and SimNet has been around for a long time now, and the Army finally decided it's time to build a replacement. We have computer technology, we have databases, we have software technology. We can go beyond this. And they led a contract to build the Close Combat Tactical Trainer. And the Close Combat Tactical Trainer is the 1990s, late 1990s revision of what we built in the 80s in SimNet. And it's replacing SimNet, but SimNet will be around for decades to come because it's a great research tool, it's a great teaching tool, it's still a great training tool until we can afford to replace it with things like CCTT and other simulators. If you sit down in CCTT, the graphics have changed from what you saw in the videotape to what you see on this slide. This is a picture of CCTT graphics. This is the quality of graphics that move around in front of you when you drive the new tank simulators around. So you can see that we've got texture mapping down, we can see through the fences. There's a lot of things that we can do now to make the virtual world a lot more realistic than we could do back in the early 80s. Here's an airborne scene out of CCTT. You can fly around in a helicopter and look down on broader expanses and change the polygon ratios on objects so that you can include more objects in the scene than you can if you're doing high detail objects in the tank's view. Now, immersion. They're low-cost training alternatives. Once you have this full-blown immersive simulator, you start cutting it into pieces and saying a fraction of that could be used in my laboratory. A fraction of that could be used in this teaching environment over here. A fraction of that could be used somewhere else. And so now you find what used to be called virtual environments or virtual worlds sliced into pieces and popping up on desktops and popping up in laboratories like this where you say, I don't need the whole thing, but you invented the technology that I can now use a fraction of in this laboratory experiment, for example. Commercial world's getting into this as well. There's an exhibit over at ITSIC on this. iSim decided to apply that tank simulation technology to driving simulators, and specifically to two kinds of driving simulators. The first being the long-haul truckers, the guys who have to get in their trucks and drive forever, and they may have to drive in snowy, icy conditions, during road emergencies, driving into a traffic jam, those kinds of things. So they get to practice in this simulator and hopefully not have so many accidents in the real world. They're building simulators as well for patrol cars, people who have to go on chases, people who have to maneuver on dirt roads and things like that. You can practice in a simulator and do a police chase in the simulator rather than doing it on the streets of San Francisco. Where's this going in the future? Most of this I don't have to tell you. You already know. You're already seeing it. If you have a home game console, you're probably playing games like Rush and Cruisin' USA and things where you're driving through these beautiful virtual worlds. Or you're playing in a fantasy environment, which sells better. But the power of the game consoles is higher than most PCs. The newest game consoles can do better graphics than your standard PC on your desk. And you're going to find that those game consoles become more and more an interactive device, that the virtual worlds in them are much more detailed. And you walk in and you find out that each object has little nuances about it. You can, I don't know, chop a tree down, whereas now the tree is just there. You can start to interact with more of these objects. And there's nothing to stop them from building head-mounted displays and gloves to interact with your home game console. Architecture and real estate is an obvious one. Architects can use tools to build the models of the Guggenheim Museum or whatever project they're working on in virtual space before doing it in the little corkboard models that you see glued to a board. Now, why would you do that? Well, one reason is through the use of head-mounted displays, I can take you through your building. So if you're commissioning me to build a building, I can show you blueprints, I can show you a little static model, and I can take you into the virtual world and show you what that building is really going to look like inside, which I can't do with those other two devices. The same with real estate agents. They'd love to be able to call you to their office and say, I'm going to take you through 10 different houses in 30 minutes, and have you sit in their office and look at the outside and inside of 10 different houses. Saves them a lot of gas. Saves you a lot of wear and tear too. And you can always say, let's go back to house number 1. And the real estate agent doesn't have to say, that's 30 minutes across town. You're killing me here. And so instead of spending all day looking at houses, you may be able to knock it out in a lunch hour. Interactive magazines. You buy Popular Science. What for? So you'll understand how a jet engine works. And instead of looking at pictures of how the jet engine works, they can include a CD so that you get in there and you go into the jet engine and you watch it spin around your head because you're in that virtual environment. There's lots of applications for this. You'll be seeing it in your entertainment applications next year, last year for that matter. Here's the best reference I know of in this area. It's called Networked Virtual Environments by Singal and Zaida. And it's a really great book. I don't have a copy of it with me, but I do have a copy of that second reference, Flight Simulation. Most of the references I'm showing you are here. This book shows you how to build simulators, what simulators do, how the different components interact, and gives you some of the history of flight simulators. Singal and Zaida's book gives you more information about how to build networked environments where you're trying to tie together multiple simulations on a computer network. So we've covered flight simulation, visual simulation, environmental representation a little bit as it evolved from shadow graphs into 3D graphics, and then finally distributed simulation. Now you know when we step into distributed simulation, we're starting to talk about interoperability. Now we're going to do simulation as a form of wargaming. Simulation as wargaming has been around a lot longer than virtual reality simulation. In fact, we're going to jump back to 1664. As a formal war game, or a modern game of war, Königspiel in 1664 was the first war game. And we've evolved lots of new rules and ways of representing the battlefield or the business field or the game board since then. But some of the ideas that emerged in 1664 and in the 1700s are still with us in the simulations we're building now. Königspiel was invented by Christopher Weykenmann in 1664. He took a checkered board and placed 30 pieces on it. And the 30 pieces represented a king, a marshal, a colonel, all the way down to the private. And each one of them was meant to carry out a certain role. And so the commander would control his 30 pieces and move them around on the battlefield. And his critics said, oh, Weykenmann, all he did was change chess a little bit. It's just like chess. You're not learning anything more than you would learn with chess. But he was saying, no, I'm trying to take you away from such an abstract view as chess and get you more in touch with what you actually will have to work with. Now the board looked exactly like a chessboard. Well, along came Dr. Heilwig in 1780. And he said, I like what Weykenmann has done. I want to change it. And he expanded the board to 1,666 squares. And he raised the number of pieces to 120 pieces. So it's a lot bigger now. But the two important things he did were, number one, he went down on the board and said, I don't want just red and black opposed to each other now. I want each square to represent a specific kind of terrain. And he painted the squares to represent mountains and swamps and fields, lakes and cities, whatever you'd be sitting on. And that gave him the opportunity to have the pieces behave different when they were on different kinds of terrain. The second change he made was that he invented the idea of an aggregate unit. He created a little block icon and said, this icon isn't an individual soldier. This icon is a group of soldiers. This is an entire infantry group or an entire squadron of people on horses. And now he had the aggregate units and the terrain board with different kinds of terrain in it. That was his two contributions, 1780. Those two ideas still carry forward to today. That's when they emerged for the first time. Then in 1797, just 17 years later, Jorge Venturi created a game with a terrible name. He called it Rules for a New War Game for Use of Military Schools. Obviously not a marketing man. He wouldn't have come up with a name like that. Königspiel sells much better. But he increased the size of the board to 3,600 squares. And he customized each one of the terrain types until he had created a representation of the French and Belgian border. And then he went to the little aggregate icons, and he created an icon for each unit in the French army and each unit in the Belgian army. And he said, now let's get it on. Let's fight out a French-Belgian war. We have the terrain, we have the pieces, and using the basic rules we have, we'll find out how the war would go. That was his big contribution, was to customize it to a real scenario. Then in 1811, Baron von Reiswitz created a very well-known game called Kriegspiel. And in Kriegspiel, he kind of backed up. He got away from the abstract board and went back to the sand table-like board, where he would represent the hills and the cities and the lakes and the rivers and the tree lines and things. And the soldiers were no longer aggregate icons. They were back to the porcelain representations of individual soldiers. So he had to have a lot of them out on the battlefield. But the thing that he added was called the general idea. And today we might call it the mission objective or the scenario. He said, you don't win a game by totally annihilating the enemy, by totally pushing them off of the board. There's lots of different ways of winning. In some cases, you may just have to control a specific geographic area, and you're the winner. In other cases, if you capture a key city, in spite of the fact that the enemy has lots of his pieces on the board, you still may win. And so he would describe up front what the objectives of the mission were. And that was his contribution. So now the game didn't just play out until you annihilated the enemy. It played until you accomplished the objective. Now, today's games include more than one objective. So there are 3 or 4 different ways to win a game. 1879, some Americans published a book called The American Kriegspiel, in which they described their version of wargaming. And they added information to those aggregate icons. Those aggregate icons originally just gave you the identity of the unit and the type of the unit. They said, we want to put information on those icons that describe their capabilities, so that the capability of one unit is different than somebody else. And we want to create unique icons for the unit at different levels of strength. So as they get attritted, you'll swap out icons on them. They also created things called markers. And the markers were laid on top of the icons to say, this guy is fatigued. His fatigue level is 10. His ammunition level is 25. And so you could modify the conditions of each one of these icons on the battlefield. And now you're capturing much more information about the real world in these very simple icons. Now they're still using the terrain board, but they came up with a new tool. They said, we're going to create a pegs and holes firing board. And it was just a simple way to determine how far away one unit could fire on another unit. You could fire so many holes over, and you could measure those off, and you didn't always have to be taking inches or centimeter measurements on your terrain board to decide if you could hit somebody. You could use the peg and hole firing board to make those decisions.